So we use some random files, random images to look into, and you can see the results here. Yeah, the torch, cards, and the Rubik's Cube is also related, and the accuracy is 100%. Welcome to our webinar, Deep Learning and Image Classification. My name is Arpad Forberger. I'm one of the application engineers here at Gamax Laboratory Solutions. So we will start with a brief introduction to deep learning using MathWorks tools and how to get started with it and what kind of support can you and where can you find. So the aim of this session is to provide a clear view of where deep learning is being applied in engineering and science and how it's driving development efforts, how you can research, develop, and deploy your own deep learning solutions. You may have also heard of some mainstream applications of deep learning, but how many of them would you consider applicable to the engineering and science domains? One such example is deep learning object detection, which is where a trained deep learning detective will scan an image or a video frame for certain objects. It not only finds if the object is in the image, it will draw a bounding box around it as well. Applications of deep learning are quite versatile. So there are different workflows and different scenarios that you can imagine for that one. So you can use these networks for classification, so where the output will be a categorical array, let's say, or even it can be a regression type of learning where the output is numerical or continuous. How to get started? So this is a typical workflow. So the whole workflow is supported by MathWorks tools, starting with accessing and exploring your data, accessing your files, whether they are in a static or in dynamic state in databases, or they can come from sensors, from various sensors. You can also use sensor fusion techniques to merge these data. There is also the labeling and the pre-processing of this data. And there are tools that helps you to automatically label your images or video frames. Then you can deploy your algorithm. You can tune the parameters. There are dedicated applications for that. That's called the experiments manager, where you can explore the hyperparameters. You can monitor the training progress, define experiments with Matlab code. And of course, you can export your results. And then you can create standalone applications from your models, and you can also include into enterprise solutions, and you can also create code for embedded devices or embedded hardwares. So there are two types of approaches, as you can see in this slide here. So you could use you can create a deep network from scratch, or you can use one of the pre-trained models that's included in the Matlab world. Okay, so if we go into our Matlab and we can go into this little example here, so there are several predefined and pre-trained networks that is ready to use. So you just call them like this GoogLeNet. That's one of the networks that we are going to use right now. So you just type GoogLeNet and it will automatically load this pre-trained network to our Matlab. Then you can use some images that can be classified using this pre-trained GoogLeNet network. So we will read this peppers figure and then we resize it, since different networks need different image sizes. And here you can see a little property list here. So this GoogLeNet has 144 layers. The first layer is the input size layer, and then we can resize the original image to be in the right format and size to be used with this GoogLeNet. And then we just simply call this classify using the net, which is the GoogLeNet, on the I, which is our image. That's image here, and then we can put the label here. So that's quite simple to do that. So that's usage of one of the pre-trained networks here. Thus we go back to our slideshow. We can see that there are also other models like the VGG or AlexNet, SqueezyNet, RushNet. There is a huge list of pre-trained networks that are suitable. Each network has its advantage and disadvantage. They differ in size and in the number of trained objects. And you can also use transfer learning for your purposes, which means you modify some of the layers of the pre-trained network to make sure that it accepts and trains your figures quite well. So here is a short list of the pre-trained networks, and we can find the full list here. So if we go to our network site, you can find all the networks and the details of them. They differ in size, as I mentioned earlier, the speed, and they also differ in speed, and also, of course, in accuracy. So you can choose based on your needs what kind of pre-trained network you would like to use. So this transfer learning is used to use an already trained network, just modify some of its layers to fit your own needs. So that's what we are going to do. So that's what we would like to see here now. So if we go to our next model, you can also tune the hyperparameters with an experiment manager, and you can also monitor the training, how it's evolving, how it's going there. Here's a small snapshot of the experiment manager, so you can set up multiple test cases, multiple scenarios, and you can start with multiple boundary conditions to see how it's evolving, and then when it's finished, you can take a look at what was the best trained model with different hyperparameters. And these parameters can be easily defined using a Matlab code approach. And then when you are finished, you can export the train network and the training information, so you can use it on your own code further. Okay, so if we go into our Matlab code here, so here that's the transfer learning example that we are going to discover now. So we load the data, so it contains merchandise data with different figures. Start with that one. Here you can see that we have different data of cubes, flashlights, caps, stickers, and USB stick. Small set of data. We will use 55 images for training and 20 images for validation. Quite short list, but that's enough for our purposes. So we can use GoogLeNet, and we can visualize it with the GoogLeNet, with the Deep Network Designer. So let's open this one. So here we can see all the layers of this GoogLeNet. It has 144 layers, and with this Deep Network Designer, it's quite easy to visualize and replace the layers that are in interest. The first one is the image input. You can see the required image sizes. You can also visualize the convolutional layers in different stacks. It's repeated 9 times. And then the final layer, that's the classification layer and output layer. So when you need someone, then you can simply replace that one quite easily. So that's a nice visualization for your layers. So let's jump back to our presentation. So we have seen we have different sets in the workflow, and it supports different solutions, different tools, and you can combine them within an X standard. So you can use TensorFlow, other machine learning tools and kits, depending on your personal interest or needs. So let's jump back to our model. So we replace the final layer, so we tailored that one to our needs, and then we can use that for our purposes. So we use this pre-trained network. That's the basic idea in this transfer learning example. And then we can use this one to train the network on our images. So we use, as we mentioned earlier, 55 of those images, and the rest 20 image is set for the validation purposes. So we can see how the training goes in real time. So you can see the training and the validation and the accuracy of that one, and also the losses, how the training forwards and progresses. And you could also use all of your cores, so you can speed up the computation quite easily. And as we progress, then the validation gets a higher accuracy, and the loss is going to 0, it tends toward 0. So that's a pretty nice approach here. So for this purpose we use GoogLeNet, but there are lots of other pre-trained networks that could be used for our purposes, and you can visualize them quite easily with the Deep Network Designer. So now we have our training set, it's trained, and then we can use this newly trained network to classify our new images based on the previously trained one. So we use some random files, random images, to look into. And you can see the results here. Yeah, the torch, cards, and the Rubik's Cube is also related. And the accuracy is 100%. The accuracy is 1. So it's quite accurate network that can detect our new images. You can also use the built-in tools to create a code for different CPUs, GPUs, or FPGAs. The code generation functionality supports all of these steps for your extended code generation needs, so you can embed the code into embedded systems. And you can also use Matlab production server to increase and scale the computation needs. So to wrap up today's presentation, currently Matlab supports the whole workflow from accessing your data, whether they are in static files or in databases, label and preprocess your data, develop the models and generate code. There are other services that you can use, like our technical support, our consulting services. There are online or offsite workshops, and also we can offer you our training services if you want to learn more on deep learning and machine learning using Networks tools. There are online on-ramp courses, so you don't need any license for that, only a Networks account, so you can use these online on-ramp courses. With this one, I thank you for your attention. Please feel free to contact us if you need more information. See you at our next webinar. Thank you.